All right, you guys, today we're doing 9.4 hyperbolas. I think maybe this would be the most challenging. You have to be really careful because this is gonna look similar to your ellipse, but it's not. And there's a big characteristic that changes it. And normally, if I remember when teaching this lesson, what happens is we definitely mix up these two. So just to then bounce on that idea, let me just show you something. We all remember when we did, and this is your last conic, and we're only gonna do it at the origin. So that's good because shifting it is a little too challenging. So if you guys remember for your ellipse, an ellipse is always an x squared plus a y squared, and it always equals 1. And then depending on, for example, I know you're like, I know this, but I want to emphasize something that's different. You know, if your ellipse is looking like this and that's your longer, remember it's along the x, then the a squared goes here and the b squared goes here. So remember, where it's longer is where a goes. Oops, a. Just right where A. And then obviously, again, ellipse is always x squared plus y squared equals 1. And then if your ellipse went obviously up and down, since these are the long ones and they're under the y, on the y, your a squared would go here and your b squared would go here. And then again, just to talk about for your focus, we all know it's c squared equals a squared minus b squared, because I'm going to come back to that in one moment. So just to kind of emphasize, again, an ellipse is a plus, right? And wherever the longer side is, in this case it's on the x, that's where the a goes. In this case it's on the y, that's where it goes. And here is your foci, right? It's a minus. Okay. Now you have that on your paper. I'm going to talk about the hyperbola, and then I'm going to go back to that to kind of compare the two so you guys can see. So hyperbola is a little bit different than everything we've done. What you have for an hyperbola is you're going to have what we call two branches. And I'll show you exactly what you mean. So let's just kind of do it like this. This would be... We'll just kind of, obviously we can go both ways. We're just gonna go along the x for right now. I'll show you the other one in a moment. So that's an hyperbola, and that's what I mean when I say there's two branches. Now, here's the first key characteristics that changes it. A hyperbola is a subtraction. So we've never done a subtraction before, so now you guys should know whenever you're seeing perhaps a subtraction. Uh-oh. Because you have to, again, I talked to you guys about this, you're going to have to distinguish between the two, or between all three of them. Oh, Lord. Well, whatever. So when you're doing a subtraction, you should know it's a hyperbola. But now here is, this marker's not working very well. Here is the other very, very important thing, and then I'll write it. Actually, let's include the important things. So, right here, those points. So this is your vertex, and this is your vertex. And the same thing, your vertex is your A value. So right now this would be A0, and this obviously would be, negative A0, right? Okay, so we have our vertex still, just like we did before with like the parabola. Remember, your focus is what it's eating. So here's a focus. Here's a focus. Let's just do, so it's negative, so it's C. In this case, we're just gonna put that there. And then you have this other value. It's not called a covertice, but you'll see how it's gonna come into play. It's the B value. It doesn't really have a name. We're just gonna go on the other axis that the hyperbola is. And this is gonna be 0B. You'll see how that comes into play. And 0, negative B. We'll come back to that in a moment. So something to realize. So it's always subtraction, and then again, a big star here, because this is what's gonna change it. So, yeah. Wherever, because I can't start it. So wherever this is my hints to you guys. So wherever the parabolas, it's, it's not really a parabola, it's a hyperbola, but wherever the parabolas, access on, it's terrible English, wherever the parabolas access on. So what do I mean, whatever, you guys, what do I mean by that? This hyperbola, shouldn't say parabola, but I want you guys to obviously realize, wherever the hyperbolas are, they're along the x-axis in this case. So wherever the parabolas axis on this axis, so this in case it's x, starts the equation. So again, and I'm going to show you both ways. That is very important. Because in the other one, this is one thing I want to emphasize, in an ellipse, what do we always start with? We always start with an x squared and a y squared, right? So in this case, because my hyperbola is on the x-axis, you will always be now you'll be an x squared. Now, here's the other difference. It is always a subtraction, y squared, however, and again, it's always going to equal 1. So make note of that. I'll just do this. Always equals 1, standard form. And then, here we go. Okay, so since it's on the x-axis, in this case, this is your vertex, so we should know that this is an a squared and this is a b squared. You're like, so if you're wondering how is it different, well, first of all, you're going to see something in a moment when I change where my hyperbola is, but right now, you guys should see a difference is the fact that I have a subtraction. The fact that your hyperbola is on the x means your x starts it. So again, write that note for yourself because that's really important. Now, the other thing I want you guys to write down, because it's the other concept that you must know, is something called an asymptote. We all know that these are the values that your hyperbola are going to approach, but never touch. So we have, in this case, 2 asymptotes. So if I ask you the key characteristics of a hyperbola, we have asymptotes, and you guys are going to have a vertice, and obviously your foci. Those are the things that are important in this in a hyperbola. So you have 2 asymptotes. In this case right now, there are 2 lines, and here's what I mean. You have an asymptote that looks like that, so it's going to approach but never touch, and you guys have something like that. Okay, so you have 2 lines, and we all know here's my equation of a line. Review. We all know m is my slope, and slope we should remember is y over x, and b is obviously your y-intercept. But right now, you guys are lucky since we're staying at the origin. All you need to know for in this case, again, it's going to change. So if we take a look at this equation, so we know it's going to be y equals, now your lines are going up and down, so it's a positive slope and a negative slope. So look at your picture. You're going to go up, because remember, it's rise over run. Try to recall that. So y first, so we're going up. Well, what value is that? That is a b value. Over, how much are we technically going over? This line should really be touching it right here. So this is an a. Ooh, no, don't write that. This is a b, because you're going up to b, and then you're going over to about a. So that is important. BA in this case. So if you're going up B over A, that is how you're going to find your asymptote. Obviously, I'm going to show you guys your example, but that's how you find your asymptote for that one. You're just going to always go up to that point and over. That's where that B comes into play. Okay? I know it's a little confusing. In the beginning, it's always a teeny bit confusing. You guys know that. Let me show you when your hyperbola is along your y-axis, and then we'll get right into our examples, and I'll show you how to find your focus. All right, so let's put them up here. So this is going to be different than obviously your other one. Okay, so let's put the key things in. So this is my vertex. This is my vertex. So I'm going to put a V and a V. And in this case, this value for the vertex is still the A. In this case, it's 0A. In this case, it's 0, negative A. Okay, then you have these B values here. So this and this B0. Negative B0 because it's along your X. So you have your focus, which is 0C, 0, negative C, and then, whoops, you have the two asymptote lines, which is going to go through your center, and I'm going to show you. All right, so in this problem then, okay, let's take a look. So how do you start a hyperbola? So here's the big difference. Okay, since hyperbola is on the y-axis, y squared starts. Very different. We've never done that before. So now it's a y squared minus, again, always minus, x squared equals 1. And then what goes in the denominator? Well, again, since your vertex is starting it, because that's where your hyperbola is, it's always going to be an a squared and a b squared. So it's kind of the reverse of your ellipse, where in the ellipse, the a squared and the b squared changes. The hyperbola, these are permanent, and these change depending on this. Now, for this one, your asymptotes, so our asymptotes are y equals plus or minus. So in this case, we're starting here. We're going up how much? Up A. So we're going up A this time and over B. So that's why this one's A over BX. It's really important. Okay? And then for this one, your focus, to find the focus. Here's a way you guys can remember it. It's just like your ellipse, except it's the opposite. What do I mean? In an ellipse, right, we start with the plus for our equation. Our focus is a minus. Well, guess what? Here's a hint. In a hyperbola, if this is a minus, this is opposite. So now this is a squared plus b squared. So it's the opposite. That is a mistake people make. Again, I would say this is definitely a hard unit when we put all of them together. Please use notes, write yourself something down. Maybe when we do the review, I'll write you all notes down. All right, anyway, let's get into doing our two types of problem, which is finding the key concepts and then writing our equations. I'll try to go quick and I'll try not to talk as much. All right, so here's our example. Find key concepts, and we'll sketch one or two of them. Now, what I want you guys to know, because again, you have to understand this, what are the key concepts for a hyperbola? Your key concepts for hyperbola is we have a vertex, we're going to have a focus, and we're going to have our asymptote, which in this case is always y equals plus or minus something x. Okay? All right, so here's question 1. X squared over 9 minus y squared over 36 equals 1. Okay, so you should know it's an ellipse because you have, hyperbola, because you have a minus. Now, here's what maybe if you guys want to do, I don't know, you can sketch it or do things for yourself. I'm going to kind of do a few ways, but write this note because even I have to sometimes retell myself this. The axis, remember, starting the equation is where hyperbola is. Write that down. Okay, so if I ask you to sketch it, so now you sketch it. So if this is starting it, whatever starts it, let's circle, which means this is your a squared. and this is your b squared. It's never changing. So if you were to sketch, okay, since we're along the x-axis, we can just draw your hyperbola. You're along your x-axis, and then if I asked you to tell me the coordinates, well, if a squared is 9, then, first of all, these are our vertices, so let's automatically write them in. So, and they're along the x, so if they're along the x, y is 0. And if our a squared is 9, then our a is 3 and -3. So obviously this is a -3 and this is a +3. Okay, so now if you want to find your focus or your foci, first of all, you should know that it's along your x again because it matches up with your vertices. To find the foci, careful, make sure you guys are doing your opposite thing. So it's going to be c squared equals a squared. So 9, opposite, so plus 36. 9 plus 36 is 45. You guys should know when you square root this, you should get plus or minus 3 rad 5. And so then come back to here, so this is 3 rad 5. And this is -3 rad 5. Okay, now for your asymptote, let's start writing this. We know it's a y equals plus or minus. So here's how you guys are doing the asymptote. Go to your picture. Remember, you have this random b coordinate. Well, if b squared is 36, b is 6. Put that in your picture. It's really easy to you guys visualize it. So now you don't have to memorize who's A over B, B over A, use a visual. So you're gonna always go up. So you're going up 6, and how much are you going over? Because again, rise over run. You have to get the y over x, that's your slope. So up 6 over 3. So this is your 6, this is your 3. Make sure you're aware of that. And then obviously you have the x, so here is your asymptote. And in this case, it's going to be b over a, but it does not matter. You don't have to memorize it. Just use a graph or the visual. Okay? All right, let's do 2 more of those, and then we'll write our equations. Second time around is always best for you all. All right, so number 2, we got a y squared minus, and again, we talked about this. Always talk yourself through these problems. I have to. All right, so what do we got going here? Remember, hyperbola. Whoever starts it, this is where it is. So this is my a squared, this is my b squared. So for hyperbola, if I'm starting it here, you should know that you're here and you're here because you're along your y-axis. A squared is 81, so that means a is 9 and -9. Let's just check the b, and since I'm already over here, we have -5 and 5. Right, you don't, it's just to have the values. Okay, so here we go for our vertex. That's the first thing. You wrote it here. It's in the y spot. So that means we must, make sure one second. It's in our y spot, so make sure you go 0, 9, 0, -9. Foci, we have to find it. So again, remember it's c squared equals a squared. Since it's a minus, now please remember it's a plus. 25. C squared equals 106. Can't be simplified, so C is rad 10 plus or minus 106. So, and again, it's in your focus, it's in your vertex spot. Okay, and then the very last thing is our asymptote. Again, don't guess. The people that make the mistakes are the ones that guess and shortcut things. 2 seconds to draw a picture. You're here. You're going to go up how much? You're going to go up 9 over 5. So there you go. Your asymptote is 9 over 5x. Done. Okay, look how fast that was. Always the second time around. All right, last one before we write our equations. So we have 25x squared minus 4y squared equals 100. Okay, minus means hyperbola. Remember, must equal 0. Oh my God. 1. Must equal 1. So that means we're going to divide everyone by 100. I think the heat is getting to me. So when you divide this, we're x squared over 4 minus y squared over 25 equals 1. Here we go, let's start it. It's a hyperbola, so circle a squared, b squared. You guys know it's starting on the x-axis. There you go. Okay, what's this value? Negative 2, 2, and then chuck this in. 5, negative 5. Really quickly, it's not a problem at all. It's pretty short once you guys get the hang of it. Talk yourself through it. Focus, I have to find c squared equals a squared, 4, opposite plus 25, and that's your hint. If you do 4 minus 25, you get a negative, can't have it. So your c squared is 29, so c is the square root of 29. So square root of 29, 0. Negative 29, 0. Great. Last step is our asymptote. Write it. Y equals plus or minus. Look at your picture. Up, over. Up 5 over 2x. That's how easy it is. Don't think, just do it. All right, let's get into writing our equations, and then we are done. Let's see, I don't want to do as many as I have on here. Focus vertex. Well, we'll see. I'll try to. I had 6, but obviously that's for in class. I'll try to get to doing maybe just 4 so you guys see 1 of each or 2 of each. We'll see. All right. So now we're going to write the equation of hyperbola given. And there's 2 different situations, okay? So the first, I am going to give you guys your focus. Now I only need to give you 1 because we're going to be at the origin. And I'm going to give you guys your vertex. Looks weird. 3, 0. Okay. However you want to do it, you guys can do it, but I am going to visually sketch it to get you guys a better understanding. So I'm going to sketch it. We all know, so 3, 0, so just all you have to do is plot 1. So here is your vertex, and here is my focus, right? Okay, so now we can start it. How do we start writing the equation? Well, where is my hyperbola on? It is on the x, so now you know it's an x squared. Hyperbola is subtraction equals 1 over. Okay, remember, these are the ones that change. These don't change. So this is always your a squared. This is always your b squared. If you want, we can write that in so you guys have it down. That's not changing. It's only those values. So this point, again, was my vertex, which is 3, 0. So this a value, here's a, here's c. You guys should do that still. The a value is 3. A squared is 9. Now, unfortunately, to find this, as you guys see, C and A, so this is our B, we have to do the work. So for the focus, or not for the focus, but to find it, write it. C squared equals A squared, opposite, so you don't lose it. What's my C squared? C is 4, C squared is 16, A squared is 9, plus B squared. Minus, you guys get B squared equals 7, so B equals, oops, stop there. I wasn't thinking. Stop there. Why? Because you want b squared, and there is your answer. Okay? All right, let's do the other one. I know this is a lot because I'm throwing all hyperbola. After we finish this one, you are done with all of your conics. So 0, negative 5, and we got our vertex is now at 0, negative 2. Okay, so again, I would sketch vertex 0, negative 2. So here it's going down. I'm just write myself a note, and then here's my focus at negative 5. All right. So where is your hyperbola? Your hyperbola is on the y. So there you go. Y is starting it. Y squared minus x squared equals 1. Okay, remember, this is not changing. This is a squared, b squared. So this distance for a squared, a is negative 2. So that means a squared is 4. Let's go ahead to find that. So here we go. C squared equals a squared plus. So 5 is c. So c squared is 25 equals, we have our 4 plus b squared. B squared equals 21. Stop there, because that's all you want for your formula. Okay? A few more and then you guys are done. All right, so that was focus and vertex as I'm sweating here. The other type of problem I can give you is I can give you your vertex. We'll do 2 more. I won't do 4 of these like I would in class. I can give you your vertex, and now I can give you your asymptote. Okay, so watch how, I ran out of room. Watch how this works. All right, so vertex and asymptote. Well, let's, like we've been doing, let's do a tiny sketch. Okay, so vertex is at 0, 3. So I'm just gonna put a 3 here. And really important, your asymptote. Your asymptote went up 3, great, over 2. Just do the positive, up 3 over 2, which means this point, which is gonna be 2, right? We talked about this, the opposite of the way you did the other ones. Up 3 over 2, which means, ding, 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 that's your B value. Okay? So watch how simple this is gonna be. Actually, don't do what I said, because the slope could be simplified. Just put the 2 there. Done. All right, so first thing, where is the hyperbola on? It's on my y. So y is starting it. Y squared minus x squared equals 1. Okay, your a value, you guys are going up. So your a value is 3. So this is 9. Now, I know this is going to be a coincidence as to what I just said, but there's a reason for it. So just do what I'm going to ask. Don't put that b value there. It doesn't pay for me to get into it. Bear with it. What I want you guys to do is to find your b value. I put a little star here. What you're going to do is you're going to set up a proportion. Okay, using your asymptote. If your asymptote line is 3, and you're going to see how this is going to change in a moment, which I probably should have done the other one. If your asymptote line is 3 over 2, we all know it's up 3 over 2, right? Okay, so in this case, 9 is my y. I'm sorry. Well, that's y squared. This, because you're going up, is your y. And also look here. Where is this vertex? It's on the y. So I'm going to put a 3 here. Bear with it. And I'm going to put in, this is y over x, and x here. Just watch. So when I cross multiply, obviously you get 6 equals 3x. So x equals 2. And in this case, remember, this is a squared, b squared. So if this is 2, it's just telling you it's under the x. You'll see what happens in a moment. Then I need to square it and get 4. I know that was confusing. Just bear with that for one moment. I know they're the same values. I'm actually going to do another one of these just to show you, so you have 3 problems more, how that doesn't necessarily the same as your asymptote. So just watch. I know you're probably a little confused. Sometimes I am too. Sorry. So watch for this one more time. If I said 0, 6, and now I said your asymptote is y equals plus or minus 3 over 4x. Okay? So if I were to, do the sketching again, or actually, I'm not going to do the sketching. I'm going to have you guys visually look for a moment. So where is it along? It's along your y. Okay, so that means you're starting with a y squared again, x squared equals 1 over. This is your a value because it's your vertex. So if it's 6, square it, we get 36. So watch how this one is going to be different from than that. Okay, so using the asymptote, 3 over 4 equals, remember, put y over x. Y is going on top, it's 6. So here's what you guys can visualize. This is a 1-to-1 ratio. This is 1 to 2. So that means what you have to think is you went twice. And that's how you got to the b value. So this is not my b value in this case. It got twice, or like we said, just do the math and cross multiply. You're gonna get 3x equals 24. So x is 8, but I want squared, so it's 64. Stare at that for a moment. I know this video is going long. I have 2 more to do. Stare at that for a moment. Yes, it's a little challenging, but set up the proportion. I know I don't want to make this long. I apologize, you guys. All right, let's do these last 2 so you guys can get done. All right, so 3. Now look, my vertex, I'll try to go faster, negative 6y. Watch, your asymptote is y equals plus or minus 3 over 2x. Okay, so here we go. Instead of sketching it, vertex A, where is it? X. So an x squared is starting it. 36. Okay, to find me this, you use your asymptote equals. You know it's y over x because that's rise over run. In this case, this is my x. So put it for your x. You want this value though. Put this is because this is x squared. Put this value, so 6. See the relationship, it's tripled in this case. So in this case, this number is tripled, or if you cross multiply, you're gonna get 18 equals 2y, so y is 9. I want y squared, 81. Okay, this is why you guys cannot just look there. Let's do just last one. Where's my book? I want to hurry up. Okay, last one, and you guys are done. Hopefully it solidifies it. 0, 8, this is your last lesson of the year. Plus or minus 2x. Let's do it. Okay, so where is it? This is again A, it's on the y, so y squared is starting. A is 8, so it's 64. Set up the proportion. Now, the slope we all know is 2 over 1. Great. Equals y over x. Use it as a guide. This is my y, so y is 8. Look, it's being quadrupled by 4. So that's how you guys know. Again, it would be 8 equals 2y. So, oops, put an x here. 8 equals 2x. So x equals 4, which means x squared is 16. I apologize, the video went long. Again, sometimes it's a refresher for myself. Please make sure you guys go back and look over all this stuff. And congratulations, you guys. This is your last lesson of the year. I know it's been a tough one, especially because it's been online, but hopefully these videos have been helpful for you guys. Sometimes in the beginning, I'm always a little bit shaky or rocky because I'm trying to review it for myself again. But hopefully the videos helped you guys. Bye.